Good morning here on the East Coast. So it's good morning. Welcome to Data Science and Telecom. I'm so excited to be here to go over this great information about how we use data science in the telecommunications industry. My name is Dr. Frances Ridley Boykin. I work for AT&T as a director of advanced analytics. I manage a team whose sole responsibility is to pull together the requisite data that we use day to day to understand our customers' uh, products, services, and interactions with AT&T. And we use that information to help us build out marketing plans, product information, as well as review customer experience and customer care efforts. So, again, welcome to this discussion on data science and telecom. So, data science is a big word. Everyone is using it, everyone is into data right now. But many times, especially those who are just entering into the conversation on data, they're like, well, how does it fit into what I do day to day? From a telecommunications standpoint, we know that we get a lot of data. So, data comes in all fashions and forms. We pull that data together and we can use it in a myriad of ways to service our customers. We have engineers and analysts who utilize our data. Again, mentioning marketing here, our marketing programs, customer experience, that's an area that I work in today. Information sales, the sale of data for information purposes. Understanding what products our customers are buying and what they're not interested in, what they are interested. We'll talk about that a little bit more. And then just service sales. How are we servicing our customers? Are we getting the installs out on time? Are we getting products to the customer on time? So those are all the things that we can do with data within telecom. So how do we manage this data? What is it? What is this whole thing about data science about with data? Well, machine learning is a part of data science, and this is the science and the art of programming computers so they can learn from data. So that's kind of how it fits together. um, Data science is the science which uses computer science, statistics, and machine learning to visualize and visualization and human computer interactions to collect, clean, integrate, analyze, visualize, and interact with the data to create data products. So all of this kind of goes in together to build out a way for us to understand our customers, our products, our services, and the use thereof. So data. Um, Back in 2011, the World Economic Forum said this, and I still use this phrase: data is the new oil. You use data everywhere. It fuels all of our work, whether you're in the telecom industry, the finance industry, the car industry, it doesn't matter. Data is so very important. And when you throw in social media and the aspects of how that data flows right into the what I call operational data that we use day to day in our organizations, it's just even more valuable. So let's talk a little bit about big data. So what's big data? Big data is just large volumes of data. So there are 5 V's associated with big data. There's volume, that large amount, velocity, how that data changes over time. We're forever looking across time to see how our customers are using our products and services and how that they're changing the use of those products and services. The variety of data. I just mentioned car buying, finance, so many areas where we can get a variety of data that we then can use to help us service our customers. Veracity. You need good data. We have that old saying, garbage in, garbage out. One of the big things that we have today is cleansing that data and ensuring that we have that data for use long term and that we can use it to make good decisions. Now, understand we have a word in big data, it's called data munging. That's that cleansing of the data and making it valuable. And then, of course, value. That data is only valuable once we turn it into information so that we can now make decisions on that data. So, very important aspects of big data. So, let's talk about what that means for analysts. So from an analytics perspective, of course, we can't do analytics without data. I remember going into a job and I get there on my first day and I was like, okay, where's my data? And my boss said, well, we don't really have a database. I'm like, no database? How can I do analytics with no database? And in that particular job, I ended up building out the database and then developing the analytics on top of it. But we all know that you have to have data to build out analytics. But there are several different levels of analytics. And depending on your organization, depending on your team, you may be on one area of the analytics scale versus the other. And there's a reason that there's a scale. So the deeper you get into data, the further out you want to look. In other words, predictive analytics, it takes more time. It's more complex to build those kind of processes and procedures. We are used to, in all industries, using the business as usual reporting that looks hindsight, tells you what the team A did versus what team B did last month. So we're used to that. We're used to dashboards that give you a plethora of information that you can slice and dice. And then we're also used to cubes and OLAP so that we can have specific portions of data that are particular to whatever we're focusing on, building us insights into a specific area. Foresight, that's where many of us want to get to. That's that predictive analytics. That's getting beyond what happened and getting into, hey, how can I impact what might happen? So that's the predictive piece of that. And as you can see, many people are at the current level, oversight, hindsight, and the desired is that predictive analytics. And many people are working towards that. So what are the challenges within telecommunications? We have a plethora of challenges that are presented to us within telecommunications, both on the infrastructure and product side and the operations side. And I've mentioned both of these already. Product recommendations, making sure our customers see what are the best products that we have that they should be purchasing. Data monetization. I mentioned this in passing already. Taking the data that I have within telecommunications, and as long as my customers agree that I can sell and utilize that data in other ways, maybe selling that data to the finance organization or a car dealership. Information about my customers that they have agreed that I can now use for other purposes and making money off of that with other orgs and other industries. Network planning and capacity management. Of course, within telecommunication, that's a big deal. How our network works, that's how we keep in business, right? So planning out where to put those towers, where are the best areas for us to focus on, where are the future areas for us to focus on. We do a lot of that. And then on the operations side, of course, there's churn analysis and prediction, making sure we understand who our customers are, where they may be in the life cycle, and whether we need to create some proactive customer care to keep those customers. I mean, we've all heard the message about it's cheaper to keep a customer than it is to build a new customer. Fraud management and ordering process optimization. That supply chain ordering process is so very important, especially during the pandemic. We had a lot of instances where the supply chain got a little wonky, and I had a friend who used predictive analytics to help him build out a way to develop an ordering scheme that allowed him to make the most out of the products that he had available to him. So if he needed 500 widgets and he had 5 orders, where's the best place to place those 500 widgets to optimize getting to our customers on time, but also making money for AT&T, which is, of course, how we all stay in business. And then fault management and root cause analysis. I don't do a lot of that, to be perfectly honest. That's not part of what I do day to day, but I know that my network partners, they really do focus on that because it's important to keep that network up and running. Hi, Durham, North Carolina. I see there. See you. I'm actually from North Carolina originally. I'm here in Atlanta today, though. So that gives you infrastructure and products, that gives you operations, and how telecom and big data can be used or integrated. So, use cases and challenges continued. So, let's talk a little bit more. Let's dig a little bit deeper. So, customer loyalty, acquisition, and retention, kind of my bailiwick. That's where I reside right now. We have a lot of customer churn analysis, but we also have some predictive models to predict churn to help us determine when our customers are at risk of churning. And then we use that to help us determine what to do next. Where should we insert ourselves from a customer care perspective to keep them from churning? Sentiment analysis. This is that big thing of going back to social media, bringing in all of that data to help us understand how do people feel about our products and services? Do we need to make some changes? Is there a big effort out there to discuss some part of our product that we haven't noticed yet? That is the sentiment analysis, and that includes this clickstream analysis as well. Clickstream is all of that online data that you get from your customers and their interactions with your company and other organizations about your products and services. So that clickstream data is very important. It helps us understand where our customers are in the process of looking at our products and services online, what they're talking about is that social media aspect, and then understanding what the funnel is from, hey, let me think about your product and service, and then let me go ahead and purchase. And then the targeted marketing, focusing on customer segmentation and profiling, understanding who your customers are. We've got to understand that. And then making the proper recommendation based on who your customers are, where they reside, and what's important to those customers and that target market. And then optimizing our plans, whether they're our customer care plans, our customer experience plans, our marketing plans, whatever our plans are, using big data and analytics can help us focus in on the right things to do for the right people. Okay. See a message here. Give me a second. Oh, awesome. Performance optimization. Really great area to focus on, and lots of data out there around, and processes as well around performance optimization. Cool area. So, moving on to data-driven improvement of network services. So, there we go. Network performance and optimization, optimizing call routing, real-time CDR analysis or call data records. So real-time CDR analysis. So optimizing call routing. My team doesn't specifically work in that area, but we do get the IVR data, and we have worked with other teams as they optimize call routing. That's a big thing. Pushing your customer to the right people to talk to, especially as we try to scale back on live conversations, because of course it's more expensive to have a live person to talk to than it is to use your web or some of our other techniques that we use for routing calls and communicating with our customers. So optimizing call routing, real-time CDR analysis, that's a big one. CDR is huge. That is like mega amounts of data, and building out the right types of NLP, natural language processing, any of that to and review of call notes. That is huge. So call notes is a big thing. And then analyzing those call notes to look for themes and areas of opportunity. Capacity optimization. Excuse me, demand forecasting. That's what my friend was working on, that capacity planning and demand forecasting. He does a lot of work in that area. It is huge because you can save a whole lot of money just by optimizing where your products and services are and having them delivered in the right places at the right time. Failure prediction, anomaly detection. That's a big one as well. I have not done as much in that area, but I do know that understanding and predicting where, for example, truck rolls, there's some failure prediction that I've seen done with trucks and when to replace your trucks, especially for field techs. So that's a cool thing that I have not actually had specific interaction with, but I know people that are working on those sorts of things. You can tailor services for new features. You can build in proactive care, again, optimizing your plans, and then GIS location data monetization. Building in your mapping, your location data with everything else that you have going on is just so cool. We are actually working on, we worked on last year a project for our network team where we did just that. We built in, hey, these are our future plans. This is what's going on with our customers today, and let's overlay that and then see which areas might be the best place for us to focus in. We can then prioritize. Maybe we want all of these areas to be serviced, but we need a prioritization. We can use big data to help us there. So, and I do believe this session is being recorded. So, security, fraud detection and prevention, anomaly detection, false answer and long call detection, unauthorized devices. Unauthorized devices, big, big, big in the telecom industry. If you're selling telephones and those stolen devices, they cost us. So, unauthorized devices, false answer and long call detection. I'm not sure if we do as much of that anymore. Anomaly detection, which of course helps us with, hey, something's odd going on here, so let's dig a little bit deeper. In all honesty, anomaly detection can even be used on not just on our customer side, but on our employee side. So let's look at anomalies. We have certain call people who are getting more calls in this area, and maybe they're doing some shenanigans there. I don't know, but we can use anomaly detection on both our customer side and our employee side. Payment processing, typical, and then data protection and compliance, always a good area for us to use big data. So let me take a quick look. I see some messages. Okay, awesome. Oh, hello from Atlanta. I'm here too. Cold today, isn't it? Amazing. It was just summer yesterday, and now it's winter here in Atlanta. All right. The data science development life cycle. So how do we develop a project around all of this data and then use it to our advantage? One of the key things for data science is business understanding. So having an understanding of the business, like you can be the best data scientist, but if you don't understand the business you're applying that data science methodology to, then you're going to struggle. So business understanding, and then digging around and building out, where's all this data? Where does it reside? How can I pull it all together? And then cleansing that data, building out that data cleansing mechanism. I mentioned earlier, we call that data munging in data science, but that's very important as well. And then data exploration. Once you get that data clean, you've got to do all of the levels of analysis to make sure that you have a hypothesis that works with the data that you have, and you're ready to then build in some good analytics. Feature engineering. A lot of people ask me, what are features? Features are just the attributes of the data that are important to your analytics. That's it. They're called features. So which elements or attributes are important for the analytics project you're working on? So those are features. And then you will use those attributes in your predictive modeling. So whatever those features are, you will then use those as part of your predictive modeling to build out your dependent and independent variables and move on. And once you have done that, then of course, you have to bring this back to leadership. So how are you going to present this to leadership? We call that data storytelling. So you then have to build out some sort of visualization to come back to, whether that's your analysts, your leadership, your executives, to build out that story to tell us now what all of this means in one fell swoop. So that's our data science life cycle. All right. Okay. So key data gotchas. What are those? There are people beyond the numbers. Remember that, remember that, remember that. There are people beyond the numbers. There are lots of variables to consider. I mentioned feature, the features in the previous slide. So the feature engineering. So the feature engineering is done because you have so many variables to consider. But what are the most important variables? What are the variables that you really should focus on? And then you're going to apply your domain knowledge, going back to the previous slide, that business understanding, applying your domain knowledge to those features to make sure that you have the right variables for the analytics problem that you are working on. And then predict versus solve. Many times people feel like, oh, I'm going to do a prediction and that's going to give me everything I need to solve my problem. Your prediction is a prediction. Doesn't mean that that's the total answer. And you will have to make sure that you're asking the right question up front and working with many people across the organization, across your ecosystem to help you focus in on the right area. And then you'll build out your solution. So you'll build up prediction, and then you'll use that with all your other domain knowledge and all your collaborative effort with everyone else across the ecosystem to build out your solution for that problem that you stated up front. So focus in on those things as it's very important. Okay, so let's give some example of real world telecom models. I've mentioned a couple of these already, but voice and data, wireless network quality overall, and at home. That's a model that we've used. Voice data, price and care importance. We've built out models around willing to recommend. That's net promoter score. How much is willing to recommend impacting or influencing our sales around broadband, with whatever that might be. Voluntary wireless churn, people who are saying see you later. How do we predict who those customers might be, and then hopefully proactively get in front of those port outs. Again, it's easier to keep a customer than it is to build a new one, or cheaper if nothing else. So building out models around port out. Early tech adopters for wireless customers, really essential there. How do we look at, who's going to buy our very new product or service? Who are those people who are willing to say, hey, I'll take a few bugs to be, on the cutting edge? And then of course, you build out some other models to help you keep up with those customers and ensure that they're getting a great product and a great product experience. Building out models around channel preference. Today, we're doing a lot around omni-channel. How do you focus in customers to where they're picking where they want to interact with you as an organization and still getting exactly what they want? That's a big one. Broadband willing to recommend. We're AT&T. That's what we do. Broadband churn with and without wireless. And then network-based churn for broadband. And again, early tech adopters. So all of these are just examples of models that we have used in the past that you might want to build out, that other companies may also be building. Okay, so I want to give you a use case. Let me check my time. Oh, okay. So let me check my time here. Not sure that I'm going to have a lot more time. So let me check really quickly, make sure there's no questions. Awesome. Yes. Great. Yes. Translating data into actionable strategies. That's what you want to be able to do. So we're about to run out of time, but I did want to also give you a quick glance into a global supply chain project that we did. Really quickly, this was a project that allowed us to improve inventory planning performance through predictive data-driven insights. This was all about using big data. And as you can see, we used a lot of data to help us understand what inventory we should have in our warehouses and ultimately at our stores. So lots of great information there. Won't have time to go through this entire project, but let me say this. We pulled together all the data, the who, the what, the when, the why, and the where. We followed our project plan. And then once we pulled all of our data together in our data environment, this is that data environment I mentioned, we were then able to leverage a collaborative filtering recommendation engine to help us focus in on the right um, products and the right stores. So there you go. We were then able to follow through on that. So there you go. I know that I've gone over just a tad, but thank you so much for sticking around and listening. I'm sure this is going to be recorded. Also, the deck itself, I do believe, will be handed over to the DSC people. So thank you. And thank you so much for joining. I will stay on. All right. Thank you.